Alright, today we are going to start talking about dilations. If you did not finish or didn't start the test on Friday yet, you need to make time to do that during a study hall. We're not going to take class time to do that, right? So you need to make sure that you're coming to me during study hall to finish that up. Also, there are some people that still haven't taken the previous quiz, right? If that's you, okay, you need to come to me to take that. I'm not going to hunt you down, right? It's just a 0 in the grade book if you don't take it, right? So that's your responsibility to come to me to make up any missed quizzes or tests, right? So you need to make sure that that's not you. So dilations is the first section in our next chapter. And a dilation is just a transformation that makes a figure bigger or smaller, right? So we actually already talked about a few transformations: rotations, reflections, and translations. Okay, this is just another type of transformation. The difference between those other three and this one is that a rotation, reflection, and translation, those don't change the size. Right? A dilation is a transformation that changes the size. So what we want to talk about first of all is thinking about doing this without a coordinate plane. Okay? What's actually happening to make a figure bigger or smaller. Okay? So in these first two examples, it says use a ruler and measure. We're just going to kind of eyeball it because we're going to focus more on the coordinate plane stuff. So what the idea is, if I want to make this line larger by a factor of 2, okay, this number right here, the R equals, is called our scale factor. So what this tells me is I'm going to double, and I'm going to multiply by 2 this length. Well, to do that, what we want to do is from our center of dilation. In these examples, S is our center of dilation. I'm going to draw a line straight from S to each coordinate point. Okay. Well, to multiply the length of AB by 2, what I'm going to do is take that distance from S to A and multiply it by 2. So I'm going to draw a line that's double that length that goes along that exact same line. Okay, so I'm just taking this distance from A to S and doubling it. Okay. I'm going to do the same thing over here. So again, technically we should be measuring this out, but for our purposes, we're just going to eyeball it here. So the distance from S to B, and then I'm just going to take that distance and double it. And so from S to B looks like about right there. So now we can say that this is my new A. And just like we did before, when we did rotations, reflections, and translations, I'm going to call this A prime. My new point I'm going to call A prime. Over here, my new B, I'm going to call B prime. And then if I connect those, my new A prime, B prime is exactly twice the length of AB. Okay, so all I did was take the distances from the center of dilation to each point and multiply those distances by the scale factor. Okay, so for example, I mean, we could say that the distance from S to A is 3. Well, then the distance from S to A prime would be double that, would be 6. Okay? If I say the distance from S to B is 4, well then the distance from S to B prime is double that, it's 8. Okay? And then what we end up with is our new line is exactly twice the length of our old line. Questions on that idea? Okay, so on the second example here, we want to make our figure smaller. I want to take each side and make it half the length. Right? So I'm going to do the same thing. I'm going to connect each of these coordinate points. my center of dilation, but now this time, I want to take half of the distance. So for example, I'm going to connect R to S, but if I'm multiplying that distance by a half, my new R prime is just going to be right in the middle of that line. It'll be half the distance. Okay, so see if you guys can do C prime and T prime here, and see where our new figure, our new triangle, is going to end up.
Is this how you do it?
What are you even talking about?
So, halfway on that line.
Not getting to it at all. Feel like you were over on I mean, that's not even Breakfast. Sorry. All right, did we end up with something like this for our second example? Okay, so this new triangle, okay, R prime, C prime, T prime, is exactly half the size of RCT. Each side is exactly half the length. Okay? Questions so far? All right, so let's now take this idea to the coordinate plane. So, in this example, we're given 3 vertices for our original triangle. So let's start by plotting those. Right? A is at -2, -2. B is at 1, -1. And C is at 2, 0. So here is my original triangle. Okay? At ABC. So now, I want to take this triangle. Now, I want to take this triangle and enlarge it by a factor of 2. Okay? Now, they tell me that my dilation is centered at the origin. Whenever our dilation is centered at the origin, all I'm going to do is multiply the coordinates by whatever the scale factor is. So in this case, my scale factor is 2. I'm just going to take each of these individual coordinates and multiply them by 2. So my new A prime, if I multiply each of these by 2, is going to be at -4, -4. My new b prime is going to be at 2, -2. And my new c prime is going to be at 4, 0. So if I plot those points, -4, -4, 2, -2, and 4, 0. Here is where my new triangle ends up. Right. So this, guys, this new triangle is exactly twice the size of my old triangle. And it even fits what we were just talking about, right? If I connect each of my original points to the center of dilation, so we said the origin is the center of dilation, right? So if I draw a line from there to A, and then I just double the length of that line along that same path, that's going to get me to A prime. I can do the same thing for each point, and I can do that for B. Draw a line from the center of dilation to B, and then double the length of that line, and I would get to B prime, right? But the shortcut, if our dilation is centered at the origin, all we're going to do is multiply the coordinates by the scale factor to get our new figure. Okay? Questions? Do what? Yeah, so on the back, we're going to do some more examples with that same idea. Okay, so do we want to do another one together, or do we feel like we can try some? Gucci. Alright, let's take a few minutes and try a couple of these then. Okay? So plot the original figure, and then to get the new figure, multiply all of your coordinates by whatever the scale factor is. Interesting.
So, I'm doing this so you don't understand.
Hey, let me see that. Let me get my whole let's go.
Alright, take a look up here, and here are the answers for 1, 2, 3, and 4. Okay, take a look up here. Okay. Even if you don't have the last 1 or 2 completely done, that's okay. Okay, but see how you did up here. Multiplying each of these by the scale factor. Okay. So on number 1, since I'm multiplying each of these by a half, my new figure is smaller than my old figure. For number 3, I'm multiplying each of the coordinates by 2, so my new figure ends up larger than my original figure. Okay? Questions on these? Questions? Alright. Then let's take a look at the last 2 here. There's my... So, I'm going to zoom in on one of these. So for both of these last 2 problems, our center is not at the origin. Okay, our center is not at the origin. So these problems are going to be slightly different. So we still want to start by plotting our original points. So I'll plot E at -2, -2. I will plot F at -2, 4. E and G at 2, 4. So here is my original triangle. Now, I'm going to dilate this by a factor of 2. So that means my new triangle is going to be bigger. But my center is going to be at the point 1, 1. Okay? My center is going to be right here instead of at 0, 0. So to do a problem like this, we kind of want to think about what we did on those first 2 examples without the coordinate plane. I'm just going to draw a line from the center of dilation to each individual point and count the distance, count how far I'm going. So for this one, I'm going over 1, up 3. Well, if I'm doubling that distance, okay, instead of going over 1, up 3, I'm going to go over 2 and up 6. Okay? And that distance is from the center of dilation, right? So my first one, from my center to my original G, I'm going right 1, up 3. So if I'm doubling that, I'm going to go over 2, up 6 from the center of dilation. Okay? I just want to do that same thing for each of my other coordinate points. So from the center of dilation, I went over 2, up 6. Right? So then I'm going to do the same thing for my other coordinate points. So for F, from my center of dilation, I'm going left 3, up 3. So from my center of dilation, I want to double that distance. So instead of left 3, up 3, I'm going to go left 6, up 6. And that's where my F prime will be. Same thing for E. Right? So from my center of dilation to E, I'm going down 3, left 3. So from my center of dilation, I'm going to double that. I'm going to go down 6 and left 6, and that'll get me E prime. Okay, so all I'm doing is finding the distance, okay, and we're not even actually calculating the distance, we're just seeing how far over and then how far up or down we're going, and then in this case, doubling that distance. So this would be where my new triangle ends up. Okay. Centered at 1, 1 with a scale factor of 2. Okay, so my new figure, the sides are all still exactly twice the length of my old figure. It's just instead of my center at 0, 0, I made my center 1, 1. Questions? All right, then you guys try number 6 here. Well, you don't have to. You can just grab it. But I was just writing them down. Just so we had them. Alright, for number 6 here, I think we should end up with something that looks like this. Okay, the green one is my original figure. And then the blue one is my dilated figure. Okay, these would be the coordinate points after the dilation.